this is Nathaniel here. Today we are now going to do something quite different. We are going to do a book review. Now, I have already reviewed 3 books, those being Randall Munro's How To, Matt Parker's Things to Do in the Fourth Dimension, and I can't remember, Cowboy's Game of Life by Nathaniel Johnston and Dave Green. However, this one's a little bit different because now we're not dealing with math anymore. We're dealing with science. Yes, you heard that right. And as somebody who has just graduated from honors, I am delighted because I had just come across this book and I just cannot put it down. So this is a really hilarious book by Stuart Ritchie, and you can look at the cover. The cover is very interesting, you see. So instead of a pH 1 to 14, we now have a pH 1 to 11 for decoding scientific fact, of course. So there's lies, impossible, nonsense, dubious, unlikely, stretching it on the boundaries from reality, plausible, half-truth, truthful, fact, and then that's the end of the scale. So this book's divided into 8 chapters and a prologue, and of course there's an epilogue, but who cares writing the epilogue in the chapter list. So first chapter is how science works, because after all that's important, and then 8 is how we can solve the problems in the middle 6 chapters. First, replication, fraud, bias, negligence, hype, and perverse incentives. Now, read this. Next, I start to enter the data column by column, row by row. I tried to imagine how the participants' answers to my question would look. Now, you see, this is an actual true story by Dietrich Stapel, and this is in his book Faking Science, A True Story of Academic Fraud. So, this is exactly what we are looking for here. So, you see, this scientist, instead of actually doing the studies, he created their own fake data. Now, this is a very obvious case of fraud. But if you want to know how science actually works, this book actually has all the answers. After all, because this is a very interesting and comprehensive guide written in the first chapter, summarized by me. So let's read the scientific literature. There's a lot of literature to go through. Then at some point you might realize, hey, there's something interesting, I want to go study it. So you create a hypothesis. Then you fund your study, usually from research grants, create a methodology section where you describe exactly what you did. Now this exactly bit is actually very important because we're going to discuss it a bit later. Then you write sections and then submit it to a journal. Now here are actual statements in actual peer reviews. They're quite funny. Stuart, this Ritchie guy, he put these statements in his book. I'm just sharing them here because I thought you might find it interesting. Now the other thing, apart from actually doing science, is how he describes what he describes scientists to be, and these are called the Miltonian norms. I took this from Wikipedia, but as you all know, you can't take stuff from Wikipedia. But in this case, the Wikipedia has a very similar gist to Stuart Ritchie's explanation of the norms. So there's communism, all scientists have common ownership on scientific goods. Universalism, scientific ability is independent on the personal attributes of its participants. This interestedness, scientific institutions act for the benefit of the common scientific enterprise. And organized skepticism, scientific claims should be exposed to critical scrutiny before being accepted. Now, number 4, well, peer review actually does the job. But 1, 2, and 3, well, you see where it goes wrong. So, here are ways in which a study might not be able to replicate. So, either there might be slight changes to the methodology, there's bad luck, like it's probably exceptional, but maybe the paper actually shows an exceptional case. An experiment might not be repeated during the course of study, and there might also be details missing on the paper. However, social science papers in Nature and Science have an average replication rate of 62% and 81% of biomedical studies that even fully describe what kind of animals or chemicals or cells were used in the experiment. That's horrible, right? However, one journal called Organic Synthesis has created a very interesting remedy to the problem. To be absolutely certain that each set of directions can be repeated, every experiment has been carried out in at least 2 laboratories. Only after exact duplication of the results in both laboratories are the directions considered ready for publication. And it has rejected a few papers, simply because the experiments couldn't be repeated. Now, we're going to talk about fraud. And one of the better known cases is that of Paolo Macchiarini. So, a snippet from his 2008 paper, actually the last paragraph on the conclusion. However, actual operations suggested otherwise. So, the BBC News guy article on Macchiarini, it's explained it well. Instead of an almost normal airway, the footage showed that the buildup of scar tissue was impeding the passage of air to the right lung. The clips also show a fistula, a hole into the rest of the body at the end of the trachea. Now, as you may see, there are a few people who have went through the same operation, and most of them are either dead or survived but hospitalized. Now, another case is that of Woo Seok Hwang. This name might be familiar to you who may have been raised in South Korea or have heard about him through because he was actually quite famous for a time until his paper was retracted. Now, you see in Hwang's 2005 paper, it's a monumental paper. As you can see here, everything went wrong. You see, the conclusion is actually very positive once you think about it. But look at this. This is the actual retraction of the paper in Science. Well, you can't believe it, right? Science actually accepted a paper which is basically fabricated. So 2 cell lines were created, only 2 cell lines, and the rest of the data was fabricated. And if that's not enough, let's meet another error called bias. So Stephen J. Gould on Samuel Morton on claims of human intelligence and skull size actually explains this well. Plausible scenarios are easy to construct. Morton, measuring by sheet, picks up a threateningly large black skull. You can read the rest yourself. So as you can see here, and you already have a conclusion in your mind. Don't fudge the results to meet your conclusion. After all, it's called science because we're testing the hypothesis, not fudging the data to meet the hypothesis. Right, let's talk about p-hacking. So, according to the American statistician, the p-value is the probability under a specified statistical model that a statistical summary of the data will be equal to or more actually than its observed value. Usually p is less than 0.05, however for other tests it will be different, of course. So p-hacking is doing many tests until p is less than 0.05 is achieved. Or you could be like the Texas sharpshooter, hypothesizing after the results are known, or more commonly known amongst the scientific community as called hacking. However, not many journal papers are published with no results, but they're actually very important because they can guide research and tell other researchers what not to do or what areas are infertile or something. Now, Now, we are going to discuss how to find statistical errors. One is to use an R package called StatCheck, created by Neuton et al. In 2015 and 2016. It's a statistical checking program based on summary data. Half of the papers between 1989 and 2023 started by Neuton et al. Had at least one numerical inconsistency, and 13% of these papers had a serious mistake. However, another test is called the granularity-related inconsistency of means test. Which is based on the principle that there are only a fixed set of values after the decimal point where the average is calculated. For example, for 3 integer values, taking the mean on it, we could have say 4.0, 5.33, 6.67, but never 7.5 or 1.5 or anything else 0.5 for that matter, because there are only a fixed set of values under the decimal point where average of a few integer values is calculated. Now, statistical errors. So this guy called Carlizo analyzed some papers by Fuji, and the patients in one of the papers show unreasonable consistency. As you can see, most of them were in the were at 0 standard deviations, and as well as a few outliers. But we can all agree that a graph like this could only be generated when Fuji created, let's say he took one row and then he would copied it 100 times and then change some of the values and say, okay, let's call it a day. Now, what about wording? What about what scientists use to describe their findings? So there are more positive ways in journal abstracts actually, and they predicted that the word novel will occur in every single abstract until in the year 2123, which is by coincidence 99 years from now. And if I did this video in 2023, it will be 100 years. And that's a very strange prediction. Alright, however, this doesn't also apply to abstracts. It also applies to statistical findings. Scientists also want significant results. And a person called Matthew Hankins in his blog, Still Not Significant, describes the many ways scientists face their p-values. and the screenshot on the right shows you a few possible wordings. Of course, there are so many more and we cannot actually go through them all. It's a very interesting blog to look through at least, but you can just read the first part. The rest is basically just results like this. Let's talk about Penger's incentives from a paper called Kwan et al. 2017, which has the very interesting title, Publish or Impoverish. Professor Gao of Heilongjiang University published 279 papers in a single journal, Actor Crystallographica section E. And as you can see, this Professor Gao, he published papers to probably, this Professor Gao created papers to get cash rewards. Maybe he could and just put all the results in a single journal, but that you still had the same results, right? Well, this kind of thing called salami slicing, it apparently artificially expands your CV, which is what we don't want. Another type of Penger's incentive is that of the predatory journal, and it's very easy to get trapped by them, and they don't even attempt peer review. That's why the predatory journal, the International Journal on Advanced Computer Technology, had this. So Peter Gampliu actually authored this, and then actually sent this to them, and then so what he had to do was pay $150 to get the paper published, but he refused. However, this manuscript's for all of us to watch, and let's face it, it's a very interesting read, isn't it? There's even a flowchart and a figure, and I think this may be what may be called the best planned April Fool's joke of them all. Now here's an interesting summary on these problems by De Vries et al. 2018. As you can see, the negative trials slowly get eliminated, or they get eliminated or marginalized or something, if I'm interpreting the figure correctly. And in summary, if you're in science for the money, don't do science. Also, if you're in science and you want to fudge the results, don't do it, because the results may say something that you never expected to come out of your hypothesis. Now here's the bibliography. As you can see, there's loads of journal papers in here and also a few websites in there. And by the way, Mr. Ritchie, you're watching this video, well, hello, I guess. And well, see you in another of my videos, I guess, because I'll never know when I'll be publishing them. Goodbye!